Hello, my name is Vegard, and in this video I'll talk about the latch and the divider component. First we can take a look at the divider component. It has one input, this is from the RAM. The job of the divider is to divide the bit streams into 8 and 8 bits. There is actually an easy way of doing this without too many calculations. When you divide a binary number by 8, it is like shifting out 3 bits to the right, so that the number you have after you have shifted out the 3 bits is actually the quotient, and the 3 bits that got shifted out is the remainder. As you can see, we have the input RAM, which is an 8-bit. Then we want to divide this into the Q and the R. The first 5 bits will be the quotient, and the last 3 bits will be the remainder. Then we can take a look at the register. Here we can see that if the reset is set to 1, then both the quotient and the remainder will be reset to all zeros. Else if there is a clock event and the clock is equal to 1, the quotient will take the value of the RAM's first 5 bits, then the remainder will take the value of the RAM's last 3 bits. And that is pretty much how you write code for the divider. Next up is the remaining bits latch. This latch will take the remainder that comes from the divider, and it also has a load, clock and reset. The latch will check whatever bit word that comes from the divider and see if it's a 0 or not. If the bit word is equal to a 0, then it will just go out and through the RBit's 0 output. If the word is not 0, then it will just continue to the MUX. As we can see in the code, we define the inputs and the outputs. Notice that the R is 2 down to 0 because it will only come 3 bits out from the divider, as I explained earlier. Then we will have to create 2 signals, both RREG and RNEX, which will also be 3 bits. The process is pretty basic. If reset is equal to 1, then the RREG will take the value of all zeros, else if the clock event and clock equals 1, then the RREG will take the value of RNext. Next state logic says that the RNext will take the value of R when the load is equal to 1. The RBit 0 will be 1 when the RREG is equal to 0. And the other output, RBit 1, will take the value of 5 zeros and the RREG when the number is higher than 0, meaning that the input remainder will just go through the latch and out through the RBit 1 and into the MUX. The 5 zeros I added is to make it a 8-bit output. Then we just simply end the behavioral and we have coded the latch.